In the previous lectures, we have created our Swarm cluster. In this lecture, we're going to actually deploy our services to the cluster. The services can be defined in our Docker Compose file. We have previously defined our Docker app and ran the services in Docker Compose file. The service definition includes which Docker images to run, the port mapping, the dependency between services. When we are deploying services in the Swarm mode, we can also set another important configuration, which is the deploy key, and it is only available on Compose file formats version 3.x and up. The deploy key and its sub-options can be used to load balance and optimize performance for each service. Let's take a look at this Docker Compose file. In the deploy key, we set the replicas to 3, which means Docker will run 3 instances of the Nginx image as a service called Nginx. So what is a replica? Let's take a look at the below diagram. When you deploy the Nginx service to the Swarm, the Swarm manager accepts your service definition as the desired state for the service. Then it schedules the Nginx service on 3 nodes in the Swarm. Each node will be running an Nginx container and is called a replica. So why we want to run the same containers across multiple hosts? This is for scalability and high availability, meaning that your application can scale when the number of users increases, and your application can still remain online even if one of your containers goes down. You might want to ask, can I access the Nginx container from any of 3 hosts? Yes, you can. As you see, we're asking Docker to publish port 80 as an available port for the Nginx service. When Docker publishes a port for a service, it does so by listening on that port across all nodes within the Swarm cluster. When traffic arrives on that port, that traffic is then routed to a container running for that service. So you can access Nginx by visiting port 80 on any of the 3 hosts. While this concept is pretty standard when all nodes are running a services container, this concept gets interesting when we have more nodes than we do replicas. Let's say you have 4 nodes in your Swarm cluster, and Swarm deployed 3 replicas of Nginx service. What if you hit 80 port of the node which doesn't have the Nginx replicas? What would happen? The answer is that you will still be able to connect to the Nginx service through a node which does not have Nginx replicas. Docker calls this ingress load balancing. The way it works is that all node workers listen for connections to published service ports. When that service is called by external systems, the receiving node will accept the traffic and internally load balancing it using an internal DNS service that Docker maintains. So even if we scaled out our Swarm cluster to 100 node workers, end users of our Nginx service can simply connect to any node worker. They will then be redirected to one of 3 Docker hosts running the service containers. All of this rerouting and load balancing is completely transparent to the end user. Besides replicas, you can configure things like limiting each replica to use at most 10% of the CPU across all cores and 50 MB of RAM. You can ask Docker to immediately restart containers if one fails to ensure that your service can always be online. Through all this, Docker aims to provide building scalability and high availability support for the service deployed on Docker Swarm cluster. Before we can deploy our Docker app service to Docker Swarm, there is another important concept we must understand: Docker Stack. This is a new concept in the Docker Swarm world. A Docker stack is a group of interrelated services that share dependencies and can be orchestrated and scaled together. You can imagine that a stack is a live collection of all the services defined in your Docker Compose file. When you have a Compose file, you can use Docker stack deploy command to create a stack from your Docker Compose file. In the Swarm mode, we can reuse the Docker Compose files for service definitions, but we can't reuse the Docker Compose commands anymore, such as Docker Compose up, Docker Compose down. Docker Compose commands can only schedule the containers to a single node. In the Swarm node, we have to use Docker stack. You can think of Docker stack as the Docker Compose in the Swarm mode. Let's see how we can deploy a stack which are composed of our Docker app and Redis services to the Swarm cluster. First, we open our production Docker Compose YAML file and add a deploy key to our Docker app service. Then we set the replicas to 2 so that we would deploy 2 Docker app containers in the Swarm. And save the Docker Compose file. Next, let's create a stack from our Docker Compose file and deploy it to Docker Swarm. This can be done through a single command, docker stack deploy. In the --compose -file option, we supply the file path to our Docker Compose file. Then, we give the new stack a name. Let's call it Docker app_stack and hit enter. Now, Docker Swarm has created an overlay network for us called Docker app_stack_default for a cross-nodes communication. This default network is created automatically when we call Docker stack deploy. Usually, we do not need to customize configuration. Then Docker creates both the Docker app service and Redis service for us. We can list all the stacks on the Swarm cluster by running docker stack ls. Right now, we only have a single stack composed of 2 services. We list out all the services in the stack by running docker stack services and provide the stack name. As you see, we have 2 services running. The Redis service has 1 replica, and the Docker app service has 2 replicas. Let's try to access our Docker app service. List the IPs of all running VMs. As we have learned before, we should be able to access the Docker app from any of the hosts because of the ingress load balancing feature of Swarm. So let's copy the IP of the Swarm node VM in the browser. We paste the IP and access port 5000. See? We're connected to our Docker app. We can also try the other host. As you see, we can access Docker app from this host as well. You might want to ask, in production, what if we want to update some of the services? What should we do? We can simply rerun our docker stack deploy command, and Docker will update our services automatically on the Swarm cluster. Let's see it in action. Let's say we want to explore port 4000 instead of port 5000. We update our Docker Compose file first and change the host port mapping to 4000. Then we will run our docker stack deploy command. See? This time it says updating services instead of creating services. Now we can list all the services. As you see, the port mapping has been updated to 4000. We can verify that by ourselves. Just go to the browser. If you try with port 5000, we get a connection refused error. If we change to port 4000, now we're connected to our Docker app. With Docker deploy, we can also easily scaling our services. Let's say we want to add one more container for the Redis service. Just add a deploy key to the Redis service and set the replicas to 2. And rerun docker stack deploy command. And list all the services. See? The Redis service has 2 replicas as well. This is the last lecture about deploying our Docker app on Swarm cluster. As a friendly reminder, if you don't want to use any VMs on DigitalOcean in the future, you should destroy them. Otherwise, they will cost you money. Don't just shut down them, because powered up VMs will cost money as well. Make sure they're destroyed.